students, I am Ekta. Previously, you have learned about problems on cards. Today, in this part, we are going to see the types of events in probability. Types of events in probability are tools that help us model and analyze different aspects of uncertainty, from certain outcomes to impossible ones, from events that cannot happen together to those that depend on each other. They are essential for calculating probabilities, making decisions, and mitigating risk in various real-world applications such as finance, statistics, and decision science. Learning outcomes. After the completion of this lesson, you will be able to define and describe the types of events in the random experiments. Understand the dependent and independent events. Differentiate problems based on events. Keywords. Events, random experiments, probability, sure events, impossible events, mutually exclusive events, exhaustive events, complementary events, independent events, dependent events. Students, let us learn the types of events in probability. Types of events in probability are sure events, impossible events, mutually exclusive events, exhaustive events, complementary events, independent and dependent events. Now, let's learn each event in detail. We have already learned sure and impossible events in class 9. And once again, we will recall them. Sure event. An event that is guaranteed to occur is called a sure or certain event. The probability of sure event is 1. Example, flipping a fair coin and getting either heads or tails, and rolling a dice and getting a number between 1 to 6. Impossible event. An event which will not occur in any case is called an impossible event. The probability of an impossible event is 0. Example, like rolling a fair 6-sided dice and getting a number greater than 6. Now, we will learn what are mutually exclusive events. Mutually exclusive events are events that cannot happen at the same time. Examples include even and odd numbers on a dice, winning and losing a game, or running and walking. For example, take two events, walking and running. A person cannot walk and run at the same time. Mathematically speaking, the intersection of these two events is 0. Now we will learn what are exhaustive events. Exhaustive events are a set of events in a sample space such that one of them compulsorily occurs while performing the experiment. Or all the events are exhaustive events if their union is the sample space. For example, while tossing a fair coin, there are two possible outcomes, heads or tails. So, these two outcomes are exhaustive events as one of them will occur while flipping the coin. Now, we will understand exhaustive events by one example of a dice. Let us consider the experiment of rolling a dice. The sample space of this experiment is 1, 2, 3, 4, 5, 6. Now, let us consider three events. Event A1 is equal to getting prime number. Event A2 is equal to getting composite number. Event A3 is equal to getting the number 1. The picture here contains events namely A1, A2, A3. Union of all these events will produce the sample space of the experiment. The outcomes of event A1 is equal to 2, 3, 5. The outcomes of event A2 is equal to 4, 6. The outcome of event A3 is equal to 1. This implies the union of all these events will reproduce the sample space. Hence, these three events are exhaustive events. Now, we will learn what are complementary events. Complementary events are two events that exist such that one event will occur if and only the other does not take place. For two events to be classified as complementary events, they must be mutually exclusive and exhaustive. The sum of probabilities of complementary events must be equal to 1. Complementary events can take place only when there are exactly two outcomes. P of A plus P of A dash is equal to 1. Let us look at a problem and understand this concept clearly. Example: a box contains 3 red marbles, 5 green marbles and 8 white marbles. What is the probability that the picked marble is not white? Solution: let us solve this problem using the concept of complementary events. Let the event of A is equal to selecting a white marble. Given number of white marbles is equal to 8, event of A is equal to getting a white marble. P of A is equal to number of white marbles by total number of marbles. P of A is equal to 8 by 16 is equal to 1 by 2. Event of A dash is equal to not getting a white marble. By applying the concept of complementary events, P of A dash is equal to 1 minus P of A is equal to 1 minus 1 by 2 is equal to 1 by 2. Answer is equal to 1 by 2 is equal to 0.5. Now we will learn what are independent and dependent events. Independent events. Two events are considered independent if the occurrence of one event does not affect the occurrence of the other. For example, imagine you have two six-sided dice, one red and one blue. When you roll these dice, the outcome of one die does not depend on the outcome of the other. Each dice has an equal chance of landing on any of its six sides. You roll the red die and get a 3. Now, when you roll the blue die, the chance of getting a 4, for example, is same as it was before. Even though you rolled a 3 on the red die, what you roll on the blue die is independent of what you rolled on the red die. These events are independent because the outcome of one die roll does not influence or depend on the outcome of the other die roll. Whether you roll a 3 on one die or a 6, the probabilities for the other die remain the same for each roll. Dependent events. Two events are considered dependent if the occurrence of one event does affect the occurrence of the other event. Example: you have a deck of 52 cards. You draw one card and it's ace of spades. Now, for the second draw, you did not put the first card into the deck. So, the deck has changed. Now, there is one less card and it's no longer a 52 card deck. It's a 51 card deck. This makes the event dependent because the outcome of the first draw affects the second draw. The probability for the second draw is influenced by the first draw. Summary of the lesson. The probability of the sure event is 1. The probability of an impossible event is 0. Mutually exclusive events are events that cannot happen at the same time. Exhaustive events are a set of events in a sample space such that one of them compulsorily occurs while performing the experiment. Complementary events are two events that exist such that one event will occur if and only the other does not take place. P of A plus P of A dash is equal to 1. Two events are considered independent if the occurrence of one event does not affect the occurrence of the other. Two events are considered dependent if the occurrence of one event does affect the occurrence of the other event. Thanks for watching this video.